Hi everyone, I'm Haneen Al-Fawri, a PhD candidate in electrical engineering at Washington University in St. Louis. Today, I am presenting our work published in the Journal of Medical Imaging on the accuracy and reliability of artery vein differentiation in small field macular OCT angiography.
OCTA enables non-invasive dye-free visualization of the retinal microvasculature at the micron level resolution. The 3x3 mm macular scan is the clinical standard for its exceptional spatial detail. However, artery vein differentiation in this field of view remains challenging. In wide-field OCTA, the optic nerve head provides an unambiguous anatomical anchor for vessels classification. In small-field macular scan, the optic disc lies outside the field entirely, leaving only local morphological cues and no standardized criteria to rely on. This is the fundamental limitation our work addresses. Retinal vessels are active indicators of systematic vascular health. Arteries and veins respond differently to disease. Arterial narrowing and hypertension, venous dilation and occlusion, vessel-specific dropout in diabetic retinopathy. This means that for any meaningful quantitative analysis, knowing which vessel is an artery and which is a vein is not optional, it's essential. And what you're seeing here is exactly what we set out to achieve: reliable AV differentiation directly from 3x3 mm macular OCTA scan. Color fundus photography provides the gold standard for AV differentiation, but directly mapping those labels into small field OCTA is not straightforward. The fields of view do not match and spatial correspondence is lost. Our solution was using near-infrared reflectance imaging readily available on commercial OCTA devices and co-registered with OCT images, serving as an intermediate spatial bridge between the two modalities. Two concentric rings centered on the fovea, standardized vessel selections across all scans, yielding ground truth labels for 465 vessels across 20 healthy eyes. Two independent annotators labeled vessels on 3x3 OCTA masked to all ground truth. The primary criteria was the periarterial capillary-free zone, or PACFZ, which is the dark halo shown in yellow arrows here around the arterial vessels in red. A supporting cue was vessels crossings. Arteries and veins crosses each other, but the same vessel type rarely does. Together, these criteria provided a structured, reproducible labeling framework. Interestingly, traditional vessel features such as diameter and intensity showed little discriminatory value in small-field macular OCTA. Arteries and veins appeared remarkably similar quantitatively, suggesting that reliable differentiation depends more on spatial vascular patterns rather than simple vessels measurements. Using these standardized criteria, both annotators achieved high reproducibility across repeated grading sessions with a mean accuracy of 93.7% and strong inter-rater reliability, reaching a Coherence kappa of 0.84. Importantly, strong agreement was also observed between independent annotators, demonstrating that artery vein differentiation in small field OCTA can be performed reproducibly. Small field OCTA offers extraordinary vascular detail with a limited anatomical context. By combining multimodal mapping with standardized OCTA criteria, we show that reliable artery vein differentiation is achievable. This work lays a foundation for future automated and quantitative retinal vascular analysis. Thank you.